Hi folks, welcome back to another session. Now we're going to look at some questions that we might be asked to deal with that go along with the idea of evaluating the validity of conjectures. Okay, here we go. So we remember all that stuff that we learned last time, the possible flaw in inductive reasoning and evaluating conjectures formed from visual properties, evaluating conjectures formed from patterns. So we're going to look at some of that here. Okay, so what we see here is which conjecture is true based on the data given. So what I see are, let's see, the first row says powers of 9, okay? And then it says the sum of the digits. So let's see, 9 to the power of 0 is equal to 1, okay? So the sum of the digits, well, there's only a 1 there. 9 to the power of 1 equals 9, so it's just a 9. 9 squared is 81. So we get 9 because we add the 8 and the 1 together, sum of the digits. 9 cubed turns out to be 729, and when we add the digits together, we get 18. 9 to the power of 4 is this big ugly number, and we add those digits together, we also get 18. 9 to the power of 5 is this monstrosity, and it gives us 27. Okay. So which conjecture is true based on the data given? So we have to evaluate all of these conjectures and see which ones make sense, or I guess only one of them must. So the sum of the digits of a power of 9 is always odd. Well, if we only looked at these first three and maybe even that last one, we might believe that, but these two numbers are definitely even. So with enough empirical evidence, we can throw that one out. A couple of counterexamples. The sum of the digits of a power of 9 is always prime. Well, there's not a single prime number there, so I don't think that works. 1 is not really considered to be a prime, so there's not a single prime number there, so that one's way out. Maybe the correct answer would be is never prime. That would be a good conjecture. Not one of the ones we have, though. It says the sum of the digits of a power of 9 is always a power of 9. Now we're getting interesting. Well, 1 is a power of 9, 9 is a power of 9, 9 is a power of 9. What about 18, 18, and 27? Well, this would be one where people might slip up because they might think that 18, since that's 2 times 9, then it's a power of 9, but it's not. The next power of 9 would be 81, right, after 9 to the power of 1. So these are the powers of 9. And we know that I don't see 18 or 27 in that list. So that one's not right. D says the sum of the digits of a power of 9 is always a multiple of 9. Yes. 0 is 9 times, oh wait, look at that. 1, is that a multiple of 9? Not really. So this one is not really correct. Maybe we should change it. A power of 9, let's say, greater than 0. So a little mistake in that question. Surprised that one got through there. So the sum of the digits of a power of 9 that's greater than 0 is always a multiple of 9. Yeah, and the rest of these are always turning out to be multiples of 9. So we certainly believe that, okay? All right. John states that vertically opposite angles, okay, so we've got to figure out what that is, and they always add up to 180 degrees. Explain why this is incorrect and state a better conjecture. So vertically opposite angles is if you draw any two straight lines that intersect in what we call an X pattern, vertically opposite angles are angles that are sort of across the X from each other. So those two would be vertically opposite, as would those two, okay? So that's what vertically opposite angles mean. So we've got sort of some sketches of vertically opposite angles here. And it says they always add up to 180 degrees. Well, what I know about 180 degrees is that all the way around a straight line, they have to add up to 180. So if this one looks like it's bigger than 90, and this one is less than 90, this one looks bigger than 90. So if I had two angles that are bigger than 90, I'm not going to get 180 degrees. No. So his conjecture is obviously wrong for that reason. Okay, and state a better conjecture. Okay, what can we say about these vertically opposite angles, or the pairs of vertically opposite angles that we've seen in all of these examples? Well, maybe a better conjecture would be, it looks to me like they're all the same size. What do you think? How about we say vertically opposite angles are congruent. That's better. That seems to work. Good conjecture. All right. So all the same stuff as last time. Good luck. See you in the next one.